Solve for a specified variable. To solve for x, you must get it by itself. You have minus 2y with it here. You want to get this minus 2y over to the right side, away from the x squared. So you're left with x squared on the left. So you move the minus 2y to the right and make it plus 2y. Now, to get the x by itself, you must undo the square on the x. So you have to have the square root of this and the square root of that, leaving you with x equals the square root of z plus 2y. To solve for x in this formula, you must begin isolating the x by ridding it of anything that is plus or minus around it. Move this over to this side. So you're left with 2 square root of x equals z minus y. You cannot do anything with the x yet until you get rid of the multiplication by 2. So divide both sides by 2 to get this. Now, to undo the square root, you must square both sides, which will give you x equals the quantity squared of z minus y over 2. To solve for c in this formula, you have to begin to unravel whatever is around c. And what's around the majority of everything on the left-hand side is a square root sign. So you need to square both sides. When you do that, it leaves you with a plus b over c equals x squared. You cannot solve for c by leaving it in a denominator. It must come out of there. So to get it out of that denominator, you multiply the left side by c and the right side by c. When you multiply by c on the left, this cancels out, and you're left with a plus b. On the right, you simply have x squared c. Remember, you're solving for c, so to get c by itself, you're going to have to divide by x squared on both sides, which will cancel out on the right, leaving you with c, and on the left, you will have a plus b over x squared. To solve for y, we have to start undoing what's around it, and the first thing is the multiplication by 2. So we divide by 2 to cancel it out, and be left with the quantity squared of x minus y. On the right, you'll have z plus 5 over 2. To undo the perfect square, you need the square root. So you'll be left with a terribly drawn x minus y, and then on the right, the square root of z plus 5 over 2. The next thing that must go is the x. So it's going to be negative y equals the square root of z plus 5 over 2, and then minus x outside of that. Next up, we have to divide both sides by negative 1. That will cancel out the negative 1's on the left, and you'll be left with y equals the square root of z plus 5 over 2 minus x, everything over a negative 1. You now have to simplify still. The division by negative 1 will change the sign of everything on the top, so it's a negative square root of z plus 5 over 2 plus x. To solve for y, we must begin to undo what is around it. So we're going to divide by 4 first to cancel these out and be left with the quantity squared of x plus 2y. On the right, you'll have a minus 2 over 4. Let's undo the square on the left by finding the square root and do the same thing on the right side. You'll be left with x plus 2y equals the square root of a minus 2 over 4. We need to move this x over to this side. So we'll have 2y equals the square root of a minus 2 over 4 and minus x outside of the square root sign. We now need to get y by itself by dividing both sides by 2. These cancel out. You're left with y equals the square root of a minus 2 over 4 minus x, all divided by 2. To solve for x, we must begin undoing everything around it. And we're going to start with this minus 3ab. So we'll have 5x squared equals c plus 1 plus 3ab on the right side. We must now divide both sides by 5. These cancel out and you're left with x squared equals, and you can put this in somewhat of an alphabetical order, 3ab plus c plus 1 over 5. And then to undo the square, you need the square root of both sides. To get x equals the square root of 3ab plus c plus 1 over 5. To get z by itself, you simply have to multiply both sides by z so that you can get it off of the denominator on the left. That cancels out and leaves you with x squared y equals z times the quantity a minus 2. Divide both sides by a minus 2. And you're left with x squared y over a minus 2. These cancel out and you have a z. To solve for b, we must start undoing everything around it, and you must go in reverse order for the order of operations. So we're going to start by moving that plus 4 over to the right and leaving 4x squared y over 3b on the left. On the right we have 2a minus 4 now. We need to have the b off of the bottom. In order to do that, we can multiply both sides by b. When we do that, it cancels out here and leaving us with 4x squared y over 3 and then equals b times the quantity 2a minus 4. And now to get the b completely by itself, you would have to divide both sides by 2a minus 4. Doing that is the same thing as dividing by a fraction over here with a denominator of 1. When you divide by a fraction, you flip and multiply. So we're going to keep the 4x to the second y where it's at, and then we will have that multiplied, of course it's over 3, and then multiplied by 1 over 2a minus 4. On the right, this cancels out, so you just have a b. Simplify to get 4x squared y over 3 times the quantity 2a minus 4. And that will equal b. To find x, we're going to have to get rid of what's with it. So you're going to multiply both sides by z to get x squared y equals z times a minus 2. And then divide by y to get x squared equals z times the quantity a minus 2 over y. And then you'll need the square root of both sides so that you have x equals the square root of z times a minus 2 and then over y. To solve for x, we must first move the 2b over to the right side and make that a negative 2b and plus c plus 1. Now we must divide by 4. If I divide by 4 on both sides, these cancel out, and you're left with the square root of x equals negative 2b plus c plus 1 over 4. Undo the square root by squaring both sides, and you're left with x equals the quantity squared of negative 2b plus c plus 1 over 4.